Hey, so Peter Math and History, and we are going to take a look at balancing formulas. So this is going to be a chemistry-based video. However, what we're going to do also looks like as if we were doing some math. Here's an example. So when you balance formulas, what do you think of? Well, don't you ever think about these kinds of problems or these kinds of equations? Well, if you have no clue what it means, we're going to explain how it works. So, balancing formulas is trying to understand how many of each atom or each element there is. Also, it's a method on how it can make things easier on understanding what type of chemical reaction something is going through. So when you have a chemical reaction, you have two things that happen. You have elements that are something like ingredients. So what we're going to say that these two elements are called reactants. Reactants. So we have two nitrogen atoms and two hydrogen atoms. That arrow is indicating the RXM, or chemical reaction. Right here, NH3, or also known as ammonium, is going to represent our product. It's just like when you multiply something, it's called the product. But we're not really multiplying anything. So there is a little bit of a problem about this chemical reaction. Also, the problem is that this doesn't seem very balanced.
Time's up.
The reason why it's not balanced is if you count each of the atoms in each element, they are not going to be equal to each other. For example, on this side, we have two nitrogen atoms and also two hydrogen atoms. On the product side, we have one nitrogen and we have three hydrogen. So, if we have 2 and 2 and 1 and 3, it's not going to work. Even if we say that this is 2 and this is 2, still not going to work. Because we have 3 and 1. We can't do this. So that's why we put these blank spaces in front of the numbers. Because putting a number in front of them is actually going to help them become a balanced formula. And it'll help us understand what just happened with that chemical reaction. So, when we have this blank space, and we have N2, for example, what we can do is put a number to change that thing, or to change that symbol. It's just like doing the distributive property. Let's say I have 8, and I have parentheses, x minus 2. If I do that, 8 times x and 8 times 2 is going to be 8x times negative 6. If I do that in chemistry, it's basically almost the exact same thing. If I add a 3 in front of the M2, two nitrogen atoms, it is going to bring me to nitrogen is now going to have 6 atoms. So that is what we can do while balancing the formulas. But how are we going to know that all of the atoms and all of everything is going to be balanced? Well, let's start by selecting one thing. So we have N2 or 2 nitrogen atoms. And we have nitrogen as 1 right there. So what can we do about the nitrogens to make them both balanced? What we can do is, since we have 2 here and 1 right there, to find the least common factor of all of the subscripts, what we can do is place a 2 right there. Now nitrogen is going to have 2. And if I put 1 right there, 1 times 2 is 2. So now we have balanced the nitrogens. We have 2 nitrogens, 1 here and 1 there. But what about hydrogen? What we can do is use the kind of distributive property system again. If we have hydrogen as a 2 and hydrogen as a 3, what can they both go into? Well, 2 times 3 is 6. But the thing is, since we already put that 2 in front of the M to make nitrogen 2, the problem is that now 2 is going to be connected with the H3. So now we have 6 hydrogen atoms. So in order to have 6, what we're going to do is place a 3 right here in front of the H2. Because 3 times 2 is going to be 6. So now this equation is balanced. We have 2 nitrogens on each side and 6 hydrogens on the other side, making this equation and this formula balanced. But hang on, why do we balance these things in the first place? The reason why is not only to help your lab partners or people to understand you and to figure out the same kind of language, but it's to do so because it follows the conservation of matter. Energy cannot be created or destroyed, or should I say, matter cannot be created or destroyed.
Rise on up!
Stay focused, Yuma.
Don't worry about me. Let's battle. Dododo Driver's gonna attack!
Yuma!
So when we are putting numbers in, we are not creating or destroying anything. That's why we can't change the original problem. The reason why we do so is now we understand the chemical reaction on like what happened. Let's try for a challenge problem. So we have our reactants right here and our products right here. What can we insert to make this equation and the formulas balanced? So let's take a look at one thing and head for the other. So what I'm going to do is pick hydrogen first because we have an H4 and an H2 and nothing else. So what I'm going to do about this is I'm going to insert a 2 in for H. So now 2 times 2 is 4. H is going to have 4 now. And then this is going to have 4. So that is going to be balanced. But there is a little bit of a problem. That 2 is also connecting to the O, or oxygen. So now we're going to have O2, 2 oxygens. So now we have 2 oxygens here, 2 oxygens there, and 2 oxygens right there. What I'm going to do is put a number 1 right there, so we are going to have O2, and put a 2 right here to make O4. So now we have 2 O2s is going to equal to O4. And we have 1 O4 on that other side. Let's split the 2. So now we already have oxygens. But what about carbons? We already have 2 to make 4 carbons right there. No, 2 hydrogens. So what are we going to do with carbon? We see that 1 right there, 1 carbon. What we're going to do is put 1 carbon there. But we still have 4 hydrogens right there. So now, this equation and this formula is balanced. And the reason why we do so is because of this. Matter cannot be created or destroyed. And that concludes the video. I hope this video has helped you with balancing formulas for chemistry. Thank you for watching Tao Ping Analyze the Math Industry. Like and subscribe.